So anytime we're talking about any points on a circle or a unit circle, the points on it are given by x and y, right? But what you know is that we can always find an angle theta that will actually use a right angle trigonometry from a long time ago to figure out things like the height from the x-axis, which is sine of q of theta, and this one here, the distance along the x-axis, would be calculated by using cosine of theta. Now, because it is on a unit circle, normally we would have used this r value, right? But since this is on a unit circle, the r value is 1. So instead of having r cos theta to find the x value and r sine theta to be the cosine, the y value, all we have to do is just use sine and cos. So basically, for any angles on the unit circle, the sides are, for the x-axis, you got cosine of theta and sine of theta. Now, the reason why we're looking at this is because this gives us a special identity that we can use in mathematics. Here is what you know. We know from a long time ago that c squared is equal to a squared plus b squared, right? We know that the r value along this part here, we said was equal to 1. So the hypotenuse of my right triangle is 1 squared. Now, the altitude squared is sine squared theta. Is sine theta. And you square it. And then we're going to do the same for the base, which is cosine of theta squared. Now, we can rewrite this as sine squared theta plus cos squared theta equals 1. We call this the Pythagorean identity. You're going to be using that to help you solve problems a lot. Now, here's what you need to know about y equals sine theta and y equals cosine theta. You know that their domain is the entire real numbers, and their y values for both of these are such that you've got y is greater than or equal to -1, but less than or equal to 1, where y belongs to all real numbers. Okay, now let's talk about how each of these functions work with respect to odd and even concepts, all right, that we studied in the past units. Sine of negative x is equal to negative sine of x. So sine is odd. If I have cosine of negative x, we're going to get cosine of x back when you simplify. So this is even. Now, let's talk about cosine and sine x and all those other things with their special rules. And the special rules that we're going to always adhere to is a thing called the cast rule. C, A, S, T, with quadrants 1, 2, 3, and 4. We know that for quadrant 1, everything is positive for sine, cos, and tangent. And what I should let you know is tangent of x is odd as well. So now, for quadrant 1, everything is positive. For quadrant 2, only sines are positive. For quadrant 3, tans are positive. And for quadrant 4, cosine is always positive. Let's do some practice problems. So imagine I have cos of t is equal to 3 over 4, right? And p of t is a point in the fourth quadrant. Find sine of t. Well, here's what we have to do. We're going to use our Pythagoras theorem that we had to use before. So just remember, it's 1 is equal to sine squared t minus plus cos squared t. Now, the fact is, you know that you have to find sine of t, right? Now, we can use this equation and plug this thing in and solve. But you could also rearrange it. So we could write it as sine squared t is equal to 1 minus cos squared t, couldn't we? So that's just an alternate form of our Pythagoras theorem. So now let's just substitute what we know. So we know sine squared t is equal to 1 minus cos squared t, which is 1 minus, well, 3 over 4 squared. Okay, so it's just substituting in. You end up with 1 minus 9 over 16, which ends up being 7. So 16 over 16 minus 9 over 16, which is 7 over 16. So therefore, sine squared t is equal to this, right? Now, we have to solve for this. So sine of t is going to be just the square root, the plus or minus the square root of 7 over 16. Now, you simplify. So sine of t is equal to plus 7 plus the square root of 7 over 4, or it's negative 7 square root 7 over 4. Now, here is the rule. Remember, cast rule. C-A-S-T. In the cast rule, our point is in this quadrant, right? In this quadrant, because cosine is only positive in this quadrant, sine cannot be here, cannot be positive here. So sine of t is equal to negative root 7 over 4. And we're done. Okay, for this problem, this is going to be a little bit of a doozy. We got some real math to work on. Okay, so you're given this basic equation. Sine of t, 3 sine of t, cos of t is whatever, right? Here is what we can use our Pythagoras theorem to do. It will allow us to find our sine of t and cos of t for that basic equation. So here's what you do. Solution is this. So here's what you do. You've got 3 sine t minus 2 cos t, and then you're going to use the second equation, the Pythagoras equation identity that we were using. And we're going to take our original equation from 1. You take it and solve for sine of t, and you get sine of t is equal to 2 cos of t over 3. Now we're going to sub that into equation number 2. So subbing into 2, you're going to get 2 cos t over 3 squared plus cos squared t equals 1. So now you're going to expand. And then what we can do is we can basically factor out a cos squared t. from the right side to get 4 over 9 plus 1 is equal to 1. So now that we've done that, let's continue with the math and let's see what we can come up with. All right. So now you're going to get in the bracket cos squared t times 13 over 9 equals 1. Now we get rid of the 13 over 9 by dividing both sides by 13 over 9, or multiplying by 9 over 13. So you end up with 9 over 13 is equal to cos squared t. And then you solve for cos squared t, which ends up being plus or minus the square root of 9 over 13, which cosine of t is equal to plus or minus, well, 3 over the root of 13. Now, we don't like radicals on the bottom, so we're going to multiply the top and bottom by the square root of 13. And you end up with plus or minus 3 root 13 over 13. And that is what cosine of t is. Now, notice that is what cosine of t is. So now, let's say that I still need to find sine of t. So let's go and do that right now. So remember, cosine of t is this. And what we can do is we can solve our first equation. So remember, our first equation was this, was solved to be sine of t was equal to 2 cos of t over 3. So what we're going to do is we can just substitute. We can actually sub this into this equation. So we have sine of t is equal to, well, 2 over 3 times the quantity plus or minus 3 root 13 over 13. Now we have some cancellation here. The 3 and this 3 cancel, and we're left with the following. Sine of t is equal to plus or minus 2 root 13 divided by 13. So sine of t is equal to plus or minus 2 root 13 over 13, and sine of t is equal to plus or minus 3 root 13 over 13. All right, on to the next question. Okay, so imagine I need you to find the value of sine of t and cos of t, okay? So you're given t is equal to 5/3 pi. And then b is negative 3/4 pi. And this last one is pi over 6. So all of these 3 triangles have certain things that are in common, okay? They have angles of, if we were looking in degrees, they are 60 degrees, 30 degrees, and 45 degrees. There are right triangles that are associated with them. In this case, they are the first triangle, which is half of an equilateral triangle, where we have corners of 30, 60, and 90. 60 degrees is 2 pi over 3 radians, and for 30 degrees, we have pi over 3 radians. For the other triangle, we have this. For the angle of 45 degrees, you have 45 degrees at both corners, but it's also known as pi over 4 in each corner. 45 degrees, which is equal to pi over 4, because I think of it as just 180 divided by 4. Now, the length of the sides of this triangle are 1, 1, and root 2. And we're going to use those for all 3 of these triangles. Whoops, I did make a small error. I need you to change 30 degrees angle to be pi over 6 radians. So just make sure you highlight this. All right. For the next one, -3/4. Let's take a look at it. All right. For the next one. So we have t is equal to the following. -3/4 pi. So now when we're doing this, we have to solve it for sine of t and cos of t. To do that, what you have to do is you have to see where our original graph starts. So imagine it starts here and it goes this far. So it goes 3/4 of the way across. So 3/4 back of pi. So that means that this angle here is pi over 4. So the acute angle here is pi over 4, which means we have a triangle that looks like this. 1, 1, √2. This is pi over 4, and this is also pi over 4. Now, we can use the cast rule for this as well. So this is just 1 and 1, okay? And this hypotenuse is 2. Remember for cast, C, A, S, T. For this quadrant, the only thing that is positive is tangent. So here's what we do. We know that our ratio for this angle of pi over 4 is for sine of t, you're going to get the following. You're going to get the ratio of 1 over √2, but it's going to be a negative because the angle is found in the tangent quadrant. And cosine is similarly calculated to be -1 over √2 for the same reason. Now, just copy down your solution. Okay, so for sine is pi, for pi of 29/6, we can think of that as, well, there are, so 29 divided by 6. Let's see, 29 divided by 6. So that's going to be 4, and so it's going to be 24, and then a 5 remainder. So you're going to have 4 pi's plus 5 pi over 6. Okay, so now if I was looking at what that looked like on my graph, I would have my initial arm here, and it would sweep all the way across to 5 pi over 6, which means this angle here is pi over 6. Now remember, our associated triangle had these angles. It had pi over 3 here for the 60-degree angle, and it had pi over 6 for this angle, the 30-degree angle. Then this was √3, this was 1, and then this was 2. So if I want sine of t, it's going to be some ratio of 1 over 2 based on opposite over hypotenuse. Okay, but because it is in the C, A, S, T quadrant, it has to be positive 1/2. But for cosine of t, our ratio is going to be √3 over 2. But because this is in the sine quadrant, this is negative. And we're okay, so let's go and evaluate sine of -19 pi over 2. To calculate that, you're going to get something like this. Sine of negative 18 pi minus 3 pi over 2. Now, because sine, if you looked at it, is a repeating function, it just keeps going and going and going on either side of the y-axis, either side of the y-axis. That means that certain values can, if I have whole periods, i.e. whole blocks of a period, in this case, the period is 2 pi. If I have 2 pi's, I can basically essentially just ignore them, because the only thing that makes the difference is going to be sine of negative 3 pi over 2, which gives us the following. Sine of negative 3 pi over 2, when you punch that into your calculator, is 1. Now, the reason why that is because the sine is 1 at 90 degrees. Now, here's your homework. So your homework is going to be these questions. Page 204, number 1 through 5 odd, number 9, 13, 15, 21, 29. It's going to take a little bit of time. Just work through it.